All right, Algebra 2, we're moving on to some harder concepts, but they're really fun, so that's the good news. You will have to study, though. A lot of this is starting in Chapter 9 is new. We're in 9.1. This is not new. We've done the distance and the midpoint formula. You probably saw them in Algebra 1 and in geometry. Our essential question is, can you find the distance between 2 points and the midpoint of the line segment joining them? The first thing I want to bring to your attention is a lot of these questions revolve around the Pythagorean theorem. The Pythagorean theorem tells us that a squared plus b squared equals c squared. Now, I like to tell my students, there are some triples. We call these Pythagorean triples, and we use these all the time. So I always tell my students to memorize them, and I would like for you to memorize a 3, 4, 5, a 5, 12, 13, a 7, 24, and 25, and an 8, 15, 17. And what this says is a lot of times you'll see a question that person A and person B were at FBA. One went home 8 miles, the other went home north 15 miles. How far apart were they? And you know that they were 17 miles apart. So these really help when you're building right triangles, and they help with word problems because you'll see them. Now, some of the word problems you still have to pay attention. So let me put your attention to another trick that I have up my sleeve. The only one you really need to memorize is this 8, 15, 17 because it is an even number. And here's why. Let's look at this 3, 4, 5. If I take the number 3 and I square it, don't I get 9? If I had to split 9 as perfectly as I could, without going into decimals, I could do a 3, 4, 5. And notice that is a Pythagorean triple. What about this 5, 12, 13? 5 squared is 25. If I had to split that the best I could without going into decimals, wouldn't I have a 5, 12, 13? And the same would go with a 7, 24, 25. So little tricks like that are really going to help us to memorize things. But let's see what else we need to know. In this chapter, we will need to know the distance formula. The distance formula tells us it is the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And you guys have probably used the distance formula a lot, so let's put it into practice. Example 1 says find the distance, I'll leave that formula up here, between point 1, which is at 6 and 2, and point 2, which is at 0, negative 2. And that's what these P1, P sub 1, and P sub 2 means. So I know I'm going to take the square root of, and I'm just taking the x's and subtracting them. Now they go from 2 to 1, so I will stick with my formula, 0 minus 6 squared plus negative 2 minus 2 squared. Well, 0 minus 6 squared is a negative 6. Negative 6 squared is a positive 36. Negative 2 minus 2 is a negative 4. And negative 4 squared is a positive 16. Well, I know that 36 plus 16 is 52. And because this is a radical, we do have to reduce. I know that this could reduce to be 4 times 13, and the perfect square root of 4 is 2 root 13. So that is the distance between 2 points. The midpoint formula is another formula that you guys have used a lot. The midpoint formula tells us that the midpoint is the average of 2 points. So notice I'm just taking the 2 x's and dividing by 2, and I'm taking the 2 y's and dividing by 2. So the next question says find the midpoint of the line segment from 4, 1 to 1, negative 5. So I'm just going to take these x's and add them and divide by 2. And I'm going to take the y's and add them and divide by 2. And my answer in this case is 5/2, or 2.5. And negative 4 divided by 2 is negative 2. All right, so the last question in our examples today is going to say this. Find the equation for the perpendicular bisector of line AB for the points A of 3, 5 and B 9, negative 3. Let P, x, y be any point on the perpendicular bisector. So I'm going to go ahead and use what we would use as the distance formula. And I'm going to take the first point and the second point. We're going to start with the x's, remember. But I'm going to take 3 minus x squared plus 5 minus y squared, and I'm going to make that equal to x minus 9 squared plus y plus 3 squared. Now the reason I need this is because remember my perpendicular bisector is going to be the exact same of point A to point B. So I'm going to go ahead, I'm going to actually blow this up and make myself a lot of room and show you the work in here. So we had to FOIL all of that. Actually, I'm going to rewrite it back out. So we have 3 minus x quantity squared plus 5 minus y quantity squared equals x minus 9 quantity squared plus y minus a negative 3, which would be plus 3 quantity squared. So on here, I have 9 minus 6x plus x squared plus 25 minus 10y plus y squared. Now remember, I could square both of these, so I'm going to get rid of all of that square root. And that is equal to x squared minus 18x plus 81. You have to FOIL all these. Y squared plus 6y plus 9. And when I start to combine these together, it looks like my y squares can cancel out. It looks like my x squares can cancel out. It looks like if I started to combine these, I would have a negative 6x and a negative 18x. So if I brought that over, wouldn't I get 12x? And it looks like I have a 6y and a negative 10y. And if I brought that over, wouldn't I get negative 16y? And then I know 9 plus 25 is going to give me to 34. Let me circle those. 9 and 25 is 34. And if I have 34 and I subtract, this adds up to be 90. If I subtract 90, it looks like I have negative 56. So they're actually looking for a line. So all of this can divide by 4. And the reason we could do that is that 0 is not effective. So we get 3x minus 4y minus 14 equals 0. And this is going to give us an equation for the line. Remember, this is a linear equation for the perpendicular bisector.